Hello, everybody. Todd, thank you for joining us today. Here at Vector, we are proud to say that we have been a channel partner with Electrolab for about 4 years now. We have enjoyed this relationship. They've been a very good partner with us. The nice part about it is that we have products across the product lines that we represent, so we don't have to force fit any one product into multiple applications. And Electrolab is a perfect example of this. It takes into account the ability to measure level accurately in very harsh environments and very remote environments. And so I'm happy to have Todd here to kind of kick us off, and we'll go through that.
Fantastic. Well, Gene, thanks for having us. Really enjoy these kind of opportunities to talk to everybody, internal and external to the company. So really enjoy that. Things are changing. Things are changing with tanks. First of all, tanks are getting bigger. We used to sell a lot of 16 and 20-foot tanks, tank sensors. Now you're 20, you're 24, you're 25, 30-foot tanks. We all know what's going on in the storage world. So everybody's trying to store as much as they possibly can, produce when times are better. But things are changing, so tanks are getting bigger. The other side is things are getting much more corrosive. We used to worry about situations where there was maybe 100 or 1,000 parts per million of hydrogen sulfide. Now we're 2,000, 5,000, 10,000, 20,000. So things are much more corrosive in the environments we're working in. The other thing is production rates are getting bigger. They're getting bigger. They're producing more. Where we would have wells at 100 barrels a day. Now you're thousands of barrels a day.
Not so much the past couple of weeks, but prior to that.
Yeah, nobody cares right second, but when we can, when we're ready, quite a bit of production, and you got to handle that kind of environment.
Correct.
And with that comes turbulence. So it's
more moving in,
more moving out. You got to put a sensor in that handles that kind of environment. The other side is maintenance cycles are getting longer. It's not like anybody's got extra people sitting around who wants to get to the bottom of a tank and clean material out. So maintenance cycles are getting longer, and the regulations are getting tighter and tighter. You have to be accurate in all environments 100% of the time, 365 days a year. You have to be more and more accurate, more and more reliable, and stuff in these environments. Because of that, not all sensors are created equal. You have to put the right sensor into the right environment, whether you're measuring multiple fluids or one fluid, you have to measure with the right device that goes into that. I'm going to talk about oil, particularly upstream oil production, because that's kind of where our roots are. But really all the lessons apply to midstream, to collection tanks and chemical tanks and water
chemical
tanks.
Industry, when we start getting stratification and emulsion layers and that kind of stuff as well.
It's all the same. It's not the same, but the same questions you really have to ask. From an oil side, the oil comes up as an emulsion. And even in the chemical business, as we're shipping material around, it's an emulsion. And then when it hits certain devices and certain tanks, it separates out. And we need to be able to measure multiple fluids in that tank as they separate out. We need to do that very reliably.
Because they're adding stuff to try to separate it out. So there's this constant change.
There's constant change, and you have to find that exact level, because we don't really want to sell the water, right? We need to dispose of it. We need to get rid of it. There are standards to those things, but we want to sell the oil, every drop that we have. And so we have to find the exact measurements of where that is. We have to get rid of the water. We have to measure the exact precision of the oil. And we have to meet standards along the way, in order to do that. When we're doing that, regardless of what industry you're in, you have to get rid of things like foam, condensate. You can't be measuring mist that's in the air. You can't measure sediment that gets onto the bottom of the tank. And you can't really be affected by things that are in the tank, agitators, the roof, the bottom of the tank, and the sediment on the bottom of the tank.
And that can change per if we're talking upstream, the battery section. If they're being trucked in, you might have more sediments. Rather than being piped in, you might have more gas.
Right. We compete against guided wave radar sensors all the time. We compete against false echoes. They have the false echoes. So you're tuning those out based on all these things that we're talking about, foam and condensate. You have to tune those out. With our sensors, you really don't have to do that. We'll go back to that in a second. But no matter what it is, you have to meet the standards in order to be able to ship that material. And so on the oil side, it's API standards. So if you're talking about custody transfer in a production tank, you have to have 1/8 inch resolution, 3/16 inch accuracy. That's the way it is. If you're at a mixing tank or a blend tank at getting ready to go onto a ship, it might only be 1/2 inch, but it's got to meet those standards 100% of the time, regardless of where that interface is.
Repeatability goes a long way.
Absolutely, and reliability, regardless of the interface. So maybe there's quite a few questions that I think you have to ask when you're dealing in a harsh environment.
Mm-hmm.
You know, the first one we find all the time is, what is the temperature inside that tank? What is the temperature of the fluid that you're trying to measure? I know what it was designed for, but it's never that way afterwards, right?
Correct.
So you have to know the average, you have to know when it gets a little hotter, you have to know where it spikes up to. Can your electronics handle that? Can the material that you're putting in that tank, can you handle that?
Correct.
Same
and that
thing.
could change yearly. I mean, it could change monthly. It just depends on what happens.
From this tank to that tank, from this part of the field to that part of the field, it can change dramatically. And all the electronics that we put into measurement are affected. Same with pressure. I find it a lot, as we talked before, about higher and higher production rates. Higher production rates mean greater degree of turbulence. If we put a device in that can't handle wave functions, it's going to flop around on the inside of the tank, there's no way you're going to do precise measurement with that. So you have to know, and you have to ask the question, what is going to be my turbulence inside of that tank, and adjust accordingly. Last, do you know what the chemistry of that tank is? As we talked before, maybe pH is going to be a little different. Maybe some of the other factors are going to be different. In the upstream production world, is hydrogen sulfide.
Mm-hmm.
Am I going to eat away at the steel? Am I going to eat away at fiberglass? Am I going to eat away at the material that's inside of there? Those rates are getting higher. What's funny is people don't tend to measure those.
No, and where do they have that measurement point?
Exactly. So you have to find those out and account for those at the installation point.
So another tank, in other applications, what would you look for? Would you look for a composition? Is that if I can tell you what percentages of what might be in there, a range? What do you look for in that?
We ask all the time, what is your estimated hydrogen sulfide that's in the fluid, that's in the air, what's in the environment? It's always about safety.
Okay. Then
it's about reliability, and then it's about accuracy. But we ask all those things ahead of time, and over the life of a well, over the life of a tank and sensor, we ask those questions again and again, because you're right, it does change all the time.
Well, even in an upstream application, like we see the picture here, the amount of H2S may not just be for the safety of your equipment, but if it's too high, then we may want to put a remote sensor down at the bottom to where they can read that. They don't have to go up top to maintain it.
Without a doubt. As you can see in the picture there's 2 men installing that sensor. That's because those tanks happen to be empty. Okay, but what you find over and over, particularly in some states, they're taking the catwalks away. There's no catwalk. We don't want men up on there. We don't want workers up anywhere near that because of the high H2S levels and the danger that goes along with that. That's when we need to look at things like wireless. We need to look at remote monitoring devices to keep technicians, truck drivers, etc., off those things. That's a very good point. One last thing to think about is the precipitates that are in the tank. Is my tank going to scale up? Do I have issues with iron sulfide? Do I have issues with scale? Do I have issues with paraffin? Just general gunk on that tank?
That could end up on your sensing element.
It's going to end up connecting to whatever sensor element you have in there. It gets corrosive, and then is that going to eat into the material? So you have to ask that and make sure we put the right material in the tank regardless. And the last question that you have to ask, given all these situations, is it still going to be accurate? Is it still going to last a long time in that environment, protect my investment? You brought up safety, and I want to make a special point about this. I think you have to ask, is the device that I'm going in certified for the environment that it's going in? Is it intrinsically safe, or is it explosion proof? Is it class 1 div 1? Not does it meet the standards, but has it gone through the process to get physically certified? And are we safe? Does it really meet the API standards, or in the chemistry world, chemical side, the standards that go along with that? Are you physically meeting the standards to do custody transfer, to do proper safe measurement that's inside of there? And then, was it installed with the local code? We find a lot of times that we'll sell a device, here's the certificate, and here's all those things. Was it physically installed to that code?
Correctly.
I think you need to go back and check those things for the safety of everyone involved. And again, is it still accurate and reliable? So I think that's really where Electrolab comes in, right? We're built for harsh environments. We're built for lots of turbulence, lots of harsh materials. More importantly, our sweet spot is measuring multiple fluids in harsh environments. That's what we're there for. So as I said in the notes that are up on the screen, there is no such thing as a false echo when you're talking about our device. Our device has mechanical reed switches that are in there with floats that go up and down, one that rides on the product, another that rides on water. And these can be adjusted for chemical environment.
So that's your interface measurement.
That's your interface. So one for the interface, one for the product that's on there. Whether it's, do you have foam, whether you have condensate, mist, the emulsion as it separates out, the floats are going to find that line based on the buoyancy that we put these floats on. It's going to find that, and it's going to stay there. There's no such thing as a false echo.
So as the temperature may rise and the density of the gas may change, that's not going to affect this?
No.
Okay.
And whether it's -40 outside or 140 outside, it doesn't affect.
And how much of a specific gravity can change because you have these weighted to a certain specific gravity? How much can that vary and still be accurate?
So we ask that question at the at the order process, at the quoting process. And so you might change, a tenth, maybe even a 15th, and they'll still find that level.
Okay.
Not a problem at all. But that's a great application question to ask along through. We have 3 different materials that we sell. The first one is steel, that works great for production tanks, that works great for certain chemical tanks, works really great in frac tanks and high volume, high turbulence tanks, because it goes in and it's a rock. It just stays there and it doesn't move. Never have to worry about that sloshing around. It also comes with a paraffin inhibitor on the top. We'll talk about that here in a second. We sell a fiberglass version of the same one. Love that for high H2S applications. Also like that for water tanks, where you're going to get that crust and that scale and that buildup that's on there. Then, as you saw in a previous slide, we also sell a flexible version of that for easier installation, easier shipment. Customers tend to love that.
Because you don't normally have, maybe you don't have a cherry picker there, and it's a 30-foot tank.
Exactly.
It's going to be difficult.
When you want to unfurl that and put that into a tank, that makes installation much easier and shipping much easier.
Hey, very much so.
As well. Bottom line, for these sensors and all of our devices, we expect that you're going to get at least 10 years worth of life out of those, if not more, and there's certainly applications where you've gone 15, 20 years. That's I wanted to bring up E9, as we mentioned very quickly. We've done a lot of business together doing this.
Even outside of your products.
Even outside of our products. All of our steel sensors have E9 treatment on it. It's a surface treatment that stops the buildup or slows the buildup of paraffins and asphaltenes. As you see on the picture there in front of you, you may get a little film, but it easily wipes off and the flows continue to go up and down. But all of our steel sensors have that included, so you don't have to worry about paraffin buildup. You don't have to worry about asphaltene buildup. It just sloughs right off. As we said, we've sold a lot of that with our friends Vector.
Yeah, we've used it in different flow meters in those applications, both in chemical market and the upstream. We've put it in analyzers as well to keep those buildups in analyzers and the valves clean, and it's done remarkably well, to the point now that we have customers that want to coat the entire vessel with that product to keep the buildup of the walls at a minimum.
In the chemical field, absolutely.
Yes.
So it's been fantastic. and a great relationship between us to bring that product to market. I wanted to end with kind of one other thing, talking about safety. We talked about how we can find the interface, and we can talk about how we can find the product. We sell an option with a third float on top of that for a high level shut-in. So you want to be conscious of not only human safety, but you want the product safety and the environmental safety. So we sell a third option where you're able to not only have the high alarm, but you also have a high alarm on a completely separate circuitry, where you're able to shut in a well, set off an alarm, set off a flag, do what you do, but you're able to do that all in one device, all in one port, completely separate circuitry, so that if you lost power, you still have that protection.
So you can have up to 3 different outputs.
You'd have 3 plus temperature on there, so you actually have 4.
4 outputs. Fantastic.
On there. So all in one device, all in one port, saves a lot of cost, wiring, etc.
One point of entry.
One point of entry. So I wanted to wrap up, maybe summarize this in a couple of sentences. We work in harsh environments, and they're getting more and more harsh. The materials that we work in, whether it's oil and gas, or whether it's water, whether it's chemical, they separate out, and you need the proper device for that environment, and you need a proper device to be able to accurately measure to the standards that you do. For a harsh environment, for multiple fluids, we make a great suite of products for that that you'd love to consider. There's over 100,000 of these pieces in the field. So pick an industry, from a frac tank to a chemical tank to production to high pressure. We did separators just the other day with great results. Over 100,000 of them out there. And they last a long time. They just work, right? So
yeah, we'd ask all the time, do y'all keep stock and that kind of stuff? And we just don't. We don't need it. We haven't had a need for it.
Our great marketing slogan is, "It just works."
It works.
It just works, right? Harsh environments. And anybody who knows us, we take great pride in our support. We'd love to go out, be at the site during installation, come out afterwards. 20 years after an installation, we'd love to answer the phone and help you work through any issues in your next project. So.
I see that on this picture, and there's one in front of me. You kind of mentioned a little bit about wireless. Is that something that y'all support, or is it an add-on, or how does that work in your group?
In the essence of time, I didn't put it in this presentation, but thank you for asking. There's a couple of devices. Our products are either hardwired or wireless.
Okay.
So you can do a 4 to 20 milliamp. You can do Modbus hardwired out, or we offer a full line of wireless devices, not only for our sensors, but for other devices as well. So you want to put your pressure, you want to do your temperature, you can take our wireless device and you can put those on there.
So it complements what you already have out there.
Absolutely, and all the products in the Vector line as well. And that opens you up to the IoT space, and you've got 5 more presentations coming up that taking this data and adding it to that. But a full line of product, and you're right, those are wireless sensors that are in that.
Good deal. Well, I appreciate it, Todd.
Thank you very much. Thank you for having me. We can answer any questions, Nikki, and bring up any topics that we missed.
Yes, that sounds great. So we do have a few questions. First one was, you talked a lot about the oil tanks. What about chemical tanks or other processes?
Sure. So our roots were are in upstream oil tanks. That's really where we started, but the product was actually built, believe it or not, for streams and viaducts in the water market. So we've taken that and put it into the upstream oil and gas market to midstream, but also works very, very well with the chemical market. And because we have the different options, steel, fiberglass, flexible, we're able to measure in all of those. Really, the only thing we change is the specific gravity of the float that's there. And so we're able to do all those things. We actually do several different chemical sites with the good folks at Vector, and works fantastic.
Well, the E9 has definitely opened that up. Yeah.
It really has. It really has. We're doing a couple different latex applications. We're doing one with a friction reducer, where we're able to use the E9 not only to treat devices that are inside, not only our devices, but some of the other things you sell, but really treat the whole vessel and gain efficiency, gain yield, extend that time between cleaning. It's been a great success for us.
Okay, great. Next question. You talked about harsh environments when measuring oil in the production tanks. Does the same point apply to water tanks and separators?
It does. Let me answer the water tank question first. We compete against a lot of product where they'll put a steel sensor into a water tank. And then you have a lot of issues with that scale and calcium, the scale and the paraffin and the iron sulfides all mixing together and eating away at those devices. It's one of the reasons why we recommend fiberglass for those device applications. It sticks a little less and it stops some of that corrosion product that goes inside of there. And then separators is another great application, and I appreciate you asking that. Separators have a very wide, thick emulsion layer. And we're able, by doing a physical measurement right in that application, to go and find that layer, find the oil layer above that, and to be able to operate reliably under the right pressure conditions and what have you. We're able to be extremely reliable in that application. So it's actually a great one for us.
Okay, great. Next question. Does Vector offer any type of training on this specific technology?
Absolutely. We can come to your site. We work well with the guys over at Electrolab. But like you said, it's very much a plug and play application. There's not a lot of setup involved. There's not a lot of, as we put it in our industry, it's so easy a sales guy can set it up. So yes, we do offer training, especially on the wireless, to get your wireless system set up. And we can do that in-house or on-site.
Nikki, one point to add to that, we really enjoy the opportunity, particularly on a first-time customer. After we ship these and you're getting ready to do the physical installation, we like to come out and oversee the physical installation and the startup. We do that on our dime at no cost to the customer. We like to be there to make sure everybody's trained, to make sure the installation goes right, make sure everything goes right. Not really too excited about a one-time customer. We like them to go on for years and years. So we work with our Vector reps in order to be there on site, to make sure everything goes well. And then, particularly in times like this, people are turning over a lot. So to come back and train another crew, to train another set of technicians, we'd love to do those things. Those are really good days for us. And so, you know, we love the field support and the folks here at Vector University.
Great. And what is this Vector University you just spoke of?
So Vector University is in-house training modules that we do. We do everything from basic instrumentation training to training of advanced instruments. We do it here in-house. It's a lot of hands-on, not tabletop type of thing. We have a PTU, a process training unit, that allows us to move fluid from one side to the other and see real world conditions. Our trainers go in and they'll manipulate different instruments and have the guys that are in the class actually go out and troubleshoot. And so we find that it retains a lot more information that way, and the customers really like that hands-on effect. We also offer test in and test out to see how the units, the participants are measured or progressing, and even can help you have a customized training modules for your guys to get them from point A to point B. And this could take over several months or several years. And so we're very happy with it. It's been a great success for us and really differentiates ourselves.
Great. Next question. You talked about API in the presentation. Can you tell some more things or explain some things that are going on with the API about gauging intents?
Sure. I sat on the API 18.2 committee that talked about safety and custody transfer and upstream production tanks. That committee has ended their work, and that's now an active chapter in the API standards. And now we're working on 3.1B, which talks about automatic tank gauging and the standards you have to meet, not only at a production tank, not only in a water tank, but also in midstream tanks, also in blend tanks, also in tanks that are at ports getting ready to ship. Setting the standards for accuracy and reliability at the factory where it's manufactured, but also at the time of installation, also at the time over the run of its life. But how do you calibrate? How do you record that data? How do you run off that and have a reliable measurement, something that you can trade off of, something that you can account off of, and what those standards. Nikki, I can tell you this, that all of those standards are getting tighter and tighter all of the time to keep up with technology. And so having us sit on that committee is vital to the way we develop our sensors. But that's where a few of those notes came in. There are standards for upstream tanks, standards for blend tanks, et cetera. And our sensors are designed to meet and exceed all of those.
Okay, great. We have another application question here. So we do a lot in larger storage tanks, blend tanks, midstream tanks. How large of a tank can your sensors support?
No, I appreciate that question. We're known for steel and fiberglass sensors, and that was our product line for, gosh, many, many years. And so the rigid sensors go up to about 30 feet. We've done a few over that, but safely 30 feet. When we came out with a flexible sensor that's in the line, now we can do up to 50 feet. And so some of these large tanks that you're referring to, blend tanks, midstream tanks, shipping tanks at ports, we actually now have a product that's extremely cost competitive from what you're used to, but we can meet those requirements for those tanks very easily.
Okay, great. And it looks like we have one last question here that's come in. The viewer is wanting Vector to talk about our service support a little more. What do we offer?
So we have a full staff of service in our group. We have on-site people that go to a plant every single day. We also have a full on-demand staff. They support the entire Vector territory from Texas, New Mexico, all the way up to Kansas, Missouri. They are talented guys. They also help with our training. That's run by our VP of Service, Josh Sims, here in our LaPorte office. And we are very proud of our organization and are willing to look at our stuff. Now, our guys are very good about going out and not just working on the device that is in question. They want to make sure that the technician or whoever's there involved with understands what they're doing, why they're doing it, what may have caused this, and then look at the application in general, not just the piece, but the entire application to see if we can help the customer prevent this from happening again, or maybe it could be an application problem that fixes this is the solution at the end of it.
Okay, well, we'd like to thank everyone for joining us today. We trust that it was a worthwhile experience and you learned from our experts here some valuable takeaways. Any closing comments from Gene or Todd?
Well, I want to thank Todd for being here with us. I want to also express that their office is in Boerne, Texas, just outside of San Antonio. So they're local. They've been a great partner for us for the last 4 years, and we want to continue that.
The same goes for us. Vector's been a fantastic partner in all of the different regions that you all cover. And from a corporate perspective, been nothing but supportive. We love working with you. And Nikki, thank you for putting this together to give us the opportunity to come and talk.
Okay, thank you so much. Everyone have a great rest of the day.
Thanks, everyone.
Take care.